Yeah, today I think we're going to talk about something that Mattia's actually been working on, and sort of experimenting with, which is obviously we all
TypeScript.
know that, yeah,
Yeah,
obviously we all know that TypeScript Go is a thing.
yeah,
And while the TypeScript based language server does work with Effect 4.0, it does not currently integrate with TypeScript Go. However, Mattia's been working on kind of a parallel fork of the TSGo
yeah,
repository,
yeah,
which embeds the LSP functionality. So maybe I'll hand it over to Mattia and you can
yeah,
talk a little bit about it.
yeah, sure. So, as Maxwell pointed out, the team around TypeScript itself has announced almost 1 year ago, a little more than 1 year ago, that for the new version of TypeScript, they're gonna use Go. And the entire TypeScript repository has now a parallel version called TypeScript Go. And people have already started playing around with it. It is almost, I would say, almost 100% feature parity with the classic TypeScript, with recent features for what's type checking and compilation. It has some quirks, but it's still already in the parity part of the features. But the editor experience is completely different story. Why? Because now we are not a plugin that's written in JavaScript. So that means that now TypeScript cannot load plugins anymore. And we have not yet a full picture from the official TypeScript team, but the thing makes sense because now the language service is a native binary. So allowing to load whatever inside of it, probably not the best, both in terms of performance and both in terms of security. So that points out to the story for the Effect TypeScript plugin. So as you know, Effect has, maybe let's start by sharing my screen. So as you may already know, Effect had a previous language service that has a lot of interesting features, but the most interesting ones are the diagnostics. And this is written in TypeScript. So what we have found out while writing this language service is that for diagnostics with Effect to be meaningful, we need a lot of type information. So that means that we cannot build something that is, for example, in JavaScript and calls the TypeScript Go APIs, because we would be cluttering and limiting the performance by the communication bridge. So that means that the only approach that we had for going on with the only approach that we had for the TypeScript Go version of the Effect language service is basically to write some kind of fork of TypeScript Go. And that's where we've created the new TSGo repository that you can find inside of the Effect organization. So this is a fork, but it's not a fork in a classic manner, in the sense that we have taken the repository, cloned, and changed everything, and we started diverging from that. But it's more a fork in a sense that, in the same way OXC lint does type-aware linting, the way we do is that we have an inner copy of the TypeScript Go sources, and then we basically recompile the standard TypeScript Go binary by adding points where we can inject our diagnostics. So that means that the new TSGo that Effect provides can run both as standard replacement for your TypeScript Go, and it will result in the same behavior. But if you enable in your tsconfig the language service plugin, that means that you now start getting the Effect goodies in a TSGo way. Okay, so I have been too much boring, so I suggest that maybe, yeah, I see people that requested the cat. But yeah.
No one cares about the LSP. Bring the cat back.
Yeah, no one cares. Everyone wants to see my cat. Okay, I'll show you the cat in the end. And I think that maybe we should go on and just show quickly how you can set it up, try it for yourself, and also beware that given TypeScript Go is a beta, I consider this version of the language service an alpha because it's built on beta features. So it's like more unstable than the TypeScript compiler itself. But feature-wise is almost in parity with the previous implementation we had. So that said, how do you get started with it? Well, it's very simple. You just run pmpx at effect/tsgo setup, and you hit enter. And now it will go through a guided setup that basically will set up the basics you need in order to get this new version to work. First, you need to provide your basic tsconfig, where the LSP rules may already be configured or needs to be configured if it is a project that you are starting with from scratch. Then it will ask where you want to install the language service, usually in dev dependencies. And then it asks you if you want to customize the behavior of the diagnostics, because in the Effect LSP, you can change the severity for each diagnostics. So that, for example, based on the way you code, if you do, for example, heavy LLM-based coding, you can like ramp up the severity of specific diagnostics in order to let your LLM have some kind of back pressure that tells, no, you're doing the thing wrong, so you cannot compile, or you can tune them down if, for example, they don't make sense for your setup. So, for example, if you want, you can change one of them. For example, you can change any unknown error context that detects any or unknown types in the effect errors or things like that. And when you are okay with the settings that you have, you can just press enter, and then it will ask you for which editors you plan to use. And based on the editors you select, it will give you hints and also pre-select some configurations in order to make your editor work with the LSP. Once you have done that, it will basically show you all of the changes that need to happen. For example, it will add a prepare script, it will add the dependency, it will create the section in your tsconfig, it will also change the schema and also enable the TypeScript Go settings in order for VS Code-based editors to pick it up. And also there are some guidance that can be useful when you have to perform some specific tasks that are in your editor or outside of the control of the current project. Now we are fine with that, so we can just say yes, and it will basically enable that. And you can see that immediately now I have TSGo enabled. Now that I have done that, what we need to do is exactly as the command says. We can run either npm install or Effect TSGo patch. And what it will do is that prepare script we had before will basically swap the standard original TypeScript Go binary with our own custom one. And now if I reload my editor, we should hopefully see that now we have indeed diagnostics that are baked by TypeScript Go. And the cat is back.
The cat has returned.
And now this is completely running off that TypeScript Go. So that means that the performance is way, 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 way faster than the previous implementation we had. Okay, so before going on, so a couple of questions I want to quickly reply. Work for monorepo? Yes, it works for monorepo as well, same as the previous version. It is easier to set up in here because given that it replaces the standard TypeScript Go binary, there isn't much to do. The only thing that you have to do is ensure that in a TypeScript config that covers the packages of your monorepo, it basically includes the plugins section. Even though TypeScript Go does not support plugins, we are using the plugins key as point to inject the language service. And this allows you, for example, to have inside of your team people that are using the old version and people that are trying out the new one, and the settings compare one-to-one. So migration or mixed setup should work without problems. And yeah, there's a question that I will answer later on. And yeah, I think that I can go on. So now that we have that, we can see that indeed we can have the basic features that we have. We have our classic and loved hover over the types to see what happens, that we can yield over the yield and see what it can be yielded. And there are also all the classic features that you will have from the classic diagnostics. But we also have something new. Because again, thanks to the performance we have, we can now invest more checking time into give more detailed diagnostics. So what does that mean? So in here we have a very simple example. It is basically just a program that accesses a file system service, and then it is run by using Effect.provide, and it uses a layer that provides everything except the file system and DDB connection. So in the end, our call to run promise cannot be performed because the type of this effect requires additional services to be provided, DB connection. The interesting part is that now that we have the performance budget to do so, we can also point inside of the diagnostic the point where the provide has happened. So that means that with one click, I can jump directly into the point where the provide happened. But we can also point out to one layer that could fix that issue. So this is very, very, very valuable information for the LLMs because they can just say, oh, this can fix. So probably I just need to adjust the layer composition in here, and that would solve the problem. And indeed, we can see that if we go here and we change our provide to our provide merge, for example, it will solve the issue we had with the file system. And this again is thanks to the new performance budget we have in TypeScript Go. And as we had before, we still have support for our refactors. You can, for example, refactor anything into an Effect.fn with failures. It will create our tagged error. It will convert our async await, try promise, and we can also have the classic refactor that the Effect teams loves, which is to toggle the type annotation, and there we are. And that's basically it for the refactors. One other new feature, and probably I am bursting through them, so if someone have questions, we can stop, but one other feature that we have is that now the TypeScript LSP, historically the TypeScript version, the Strada version, was not built respecting 100% the LSP protocol. It was kind of a mix of the LSP protocol and a custom protocol. And that is because historically the Strada version was built before the LSP protocol was a thing. The LSP protocol was inspired by the protocol that TypeScript Strada introduced. So some features were not possible in the previous iteration because it was not right LSP protocol. But now we can have features, for example, in here you can see that on the left, I have my outline that the editor provides. And now in here, we have as well custom entries that allows you to quickly jump into part of your effect code, and they are grouped by what they represent. For example, you can see all of the services declared in this specific file, or you can see the layers that are declared. For example, we have here an APR config live, a JSON placeholder live, and an app layer, which is a composition of layers. You can see quickly in here also which are the types that are required and provided, and also same as well for your errors. And this is very nice because when you need like to review your code or jump quickly from one part of the other of the code, I personally use a lot the outline, but again, that depends on your use case. And again, this works also from the top bar, which is this kind of the same API that allows you to change where you want to jump.
Super cool. Love it.
Feature for banning all vanilla API would love this effect first development. So good news, there is already a rule that does exactly that. It is off by default, but again, if you run again pnpx effect TSGo setup, and you choose again, there is a rule that's called node built-in import when importing Node.js built-in modules that have Effect native counterparts. And this rule is very useful when doing LLM heavy development because you can force that to be an error, so that basically you can ban in your codebase import from the node file system. And now if we apply that, if we try, for example, and now in here, I can, oops, I hate when you open it like that. Okay, you can see that we have in here an error, and yeah, prefer using file system from Effect instead of using the Node.fs module. So this can help you steer a lot your LLM towards preferring effect-driven patterns that are more testable instead of relying on built-in modules. This is one, and I have another one coming up for other global APIs. There is, for example, another one for using JSON parse and JSON stringify that instead, if we have JSON.stringify, whatever, and we do that inside of, for example, Effect.chen, we do const x equal, let me just assign that to a program, JSON.stringify. You can see here that is already suggesting consider using effect schema for JSON operation instead of JSON parse, JSON stringify. So again, this by default is a suggestion, but you can go into your tsconfig and you can change the severity. For example, you can see that now also the tsconfig supports autocompletion for your rules, and that is baked by a custom version of the tsconfig JSON schema that when you run the setup command gets automatically injected. And now we can say, for example, JSON prefer schema over JSON, and we can say error. And now when we save and we go back to our example, you can see in here that now it is an error indeed. And so always try to ban LLMs from using Node.fs. Yes, we have just replied. I ended up writing a bunch of OX-linked rules to prevent native APIs and giving hints what to do instead. Yeah, sure, that's covered, the same exact feature. If you have other native APIs that are not covered yet by a diagnostic rule, again, the LSP TSGo version is in alpha, but I am open to issues. I also have backported some of the features that are in the TSGo version to the standard version. So if there is some global API that you want to enforce instead the effect version pattern, yes, we can force that. I love this, but won't this be kind in vain when the plugin system ship for TSGo? They do want to have a plugin system, right? It's not clear right now. There is like clear statement about what the API story will be for TypeScript Go, but most probably there won't be plugin systems for TypeScript Go. There will be new CLIs that wrap around the API provided by TSGo, but unfortunately, it seems that the plugins won't be a feature. Is the outline that was shown an LSP feature or a VS Code feature? It is an LSP feature. So right now, if we go to our services, we go to live with Pipeable, you can see in here that we have the comment that describes the layer composition, and you can go to show outline and it will open to you again a Mermaid chart that you can now see and navigate. That is an LSP feature that is basically coded inside of the language service, and whenever we hover something, the language service injects in the JSON doc for that entry the information for the outline. And I would also say one other thing, that is that now that we have basically our own version of the TSGo binary, that means that by default, the diagnostic we see in here for the editor are also feedback by default for the LLM. So that means that if we run pm tsgo and we run -p tsconfig.json, we'll see that the same diagnostic that we see in our editor now are by default also in your TSGo comment. And
nice.
yeah, in my experience, that's super nice because LLMs are lazy as so even if you have a check command or whatever in your script, in your harness, whatever, you'll find out that the LLMs, when they got into a very like deep-minded process of coding something, what they'll end up doing is call TSC directly for TypeScript Strada or TSGo when you use TSGo. And that means that if we had the TypeScript effect diagnostics on another place that's not the standard TypeScript Go binary, that means that the LLM would have basically avoided them. And instead, by having this, that means that by default, the LLM gets them immediately. And you can see, for example, how nice now this information can be for an LLM to adjust this error by knowing, for example, where the provide happens and where the layer is defined.
I have a selfish feature request.
Yeah, go on.
Can we get a sub command for the CLI that you built that just allows us to turn rules on and off?
That just, yeah, I mean, by using the setup, yeah, basically skipping, yeah.
Yeah, this way we don't have to go through all of the other steps. We can just literally go to rule, or maybe setup can detect if it's already I don't know, but it would be nice because
Yeah.
I find myself when I'm using the LSP very often going to the README to look at the rules names and everything like that.
Yeah.
But being able to use the the CLI to just turn rules on and off would be super nice.
Yep.
This is already super
also,
cool.
Also another thing that you remembered me, I should mention, is that one annoying stuff of the previous Strada version, again, as I mentioned before, is that it wasn't fully LSP compliant. So that meant that for some editor, I know, for example, from VSTLS that's used by NVim, for example, the quick fixes won't appear. So you didn't have by default the ability, for example, to say, okay, I want to disable this warning just for this line. And in VS Code was really easy because it supported that custom protocol, but that was not the case for other editors. And the way that we did it in the previous version is that you had it as a refactor instead. But now that being a standard LSP, that means that now technically they should work with any editor. And so whenever you have over any diagnostic, you can just say, yeah, I want to disable that for this line or for the entire line, and should work more reliably than before, because before it was a madness. But I think that's a good idea, maybe to have a feature that you run a command and you jump directly into severity configuration by skip maybe the other thing, probably just selecting the tsconfig and then jumping straight on into the configuration of the severities for the entire project. I have also an ongoing restructure of this command because it's not so useful to see the rule names like this. Yeah, sure, you see the name, you should see what you do, but I have an ongoing restructure that will show in this CLI as well for each rule a quick and small example of when it triggers and what it will show off. So if you don't know the rule, you don't understand fully what it's showing off, you can see an example that basically shows what it will fix.
Perhaps you can address the question about keeping this in sync with TSGo at this point.
Yeah, so it will be kept, the way the repository is structured. Let me open it up real quick. There we go. So let me increase a little the zoom so we can just see it. Okay, so keeping it in sync with TSGo. So the way that it will work is that for now TSGo is in beta. So that means that there is no guarantee between one pre-release and the other that they behave in the same way. But at some point, TSGo will have one first stable release, or like a one first release, and we'll start having different release. The way that the TypeScript, the TSGo version of the Effect plugin is built is that we have basically a TypeScript Go submodule. We have some patches over it that inject just, for example, a couple of callbacks, just one callback that gets called. And the way that it's going to work is that when TypeScript Go will enter a couple of stable version, what will happen is that we will have CI jobs that basically what do, they change the commit at which the TypeScript Go submodule is pinpoint. It will run a couple of commands that generate some bridge code and then build. So that means that by going into having some like middle grounds, we will be able to still be able to support couple of latest versions of standard TSGo. So in that way, you can still have updates to the LSP while pinpointing a specific version of TSGo. And what will also happen is that the setup command, when there will be an official version of the TSGo, the setup command will also fetch and use the specific version of the patched binary that is built on top of the version that you have pinpoint. So that basically the switch will be just a recompilation with additional features. You won't have different versions because you adopted the Effect one.
I can use TSGo in library, and these libraries could be used as dependencies on programs that not use TS. I'm not sure I understand. Do you get
I think that you mean using TSGo to build libraries, and then the libraries that you have built do not use TSGo. If that's the question, yes, because in the end you just emit TypeScript files, .dts and JavaScript files, so the tooling does not care. If that's the question, not sure. I've interpreted the question in that way. Exactly. Okay. Yeah. So if that's the case, yes. In the end, the TSGo or TSC, in the end, they just output JavaScript file and the .dts file. So it doesn't matter if you are using one or the other.
Oh God, I'm already
Also,
getting questions about the next
your
version of the
question
website. I regret. I'm not actually working on it. Never mind. It's not in progress.
It was a troll.
It was a Freudian slip.
I also wanted to say, now that you have mentioned it, the reason why I mentioned before we still have this plugins field is that for that exact same reason, that you can have projects built with TSGo, projects built with standard TypeScript, but also inside a single project you can decide to use the Effect TSGo to build your project, but you can use, for example, the classic language service for your editor because maybe you prefer that. But yeah, that's the gist. We spoke last week about Effect.fn, right? So roll back to what we did like last week. We mentioned that probably when you have in your code patterns as this, for example, when you have like an arrow function that returns an effect, that's probably a great opportunity to instead use Effect.fn, because that allows, again, to first, in case the body of the effect is implemented as a generator, it avoids to reallocate the generator for each invocation of the function by reusing the same allocation each time, but also it improves the traces if you are using a traced version of Effect.fn. And so I wanted just to show off and remember, for those of you who wouldn't know, that in the LSP there is a setting that you can do, and is Effect.fn. And by default, this setting has basically few variants that controls whenever you can suggest and should use Effect.fn instead of like the arrow function or the function returning an effect. And you can say by default it is span. So by default, the LSP will suggest using Effect.fn only if and only if there is Effect.span. So if we have something like this, the LSP will suggest you to use, maybe if I say, it will suggest to use the Effect.fn, but there is also this setting. Let's see if it works, or if I break something. If you use, you have also inferred span, which means that in all of those locations where the function is exported globally or is a method of a service, you can basically infer the name from the span by having the name of the span being the exported function or the service name dot the method name. So if I enable inferred span and I go back to my service, yes, you can see here now that the diagnostic triggers can be written as reusable function Effect.fn JSON placeholder.get to do, and it also has quick fixes that says, okay, just rewrite as Effect.fn, and there you go. And now you have Effect.fn, and that's really handy. Again, if you're writing application code, you can basically set that setting all together with, for example, saying that Effect.fn opportunity to be an error, So that way you can force your LLM to do basically correct tracing of your effect services. And there you go. So basically that way you can enforce your LLM to provide good span names for your services. And also again for globally
and
exported
so
things.
having span and inferred span is required in the config?
It depends. Let me try to say it in a better way. So the Effect.fn opportunity setting that you see here is the setting that controls the severity you want for the message.
Right.
And Effect.fn controls which kind of patterns should be reported by the Effect.fn opportunity. And the default is span, which means that with span, it will suggest to use Effect.fn only if it was an arrow function that returns a generator with a span name. So if you already provided a span name, it will suggest to rewrite to an Effect.fn. Inferred span is an additional setting that says, okay, other than where I already have set a span name, you can also suggest me locations where you could probably infer the span name either from this service name. In this case, we have just seen, we have a JSON placeholder service. So it can be JSON placeholder dot the name of the method. And also things like const my method equals our number fact succeed arg. Okay. And it can also be set up in order to trigger in this kind of situations as well. And there are also other settings. For example, we have suggested span, which is suggested in a less strong way by the inferred. The inferred, again, is very hard, and suggested span instead is basically wherever it sees that there is a complex enough function that probably could better, but also untraced. And untraced, for example, should trigger for, let me see if it works or if I have a bug in here. Yeah, I probably have a bug in here because it should trigger by setting the untraced, it will trigger for any function that returns an effect that's not an effect.fn.
Okay, cool.
Not sure.
Is the TSGo LSP v4 only? Yes, I think.
No, it is both v4 and v3.
Mattia the goat.
It has, if you go to the, let me, my window management today is not good. If you go to the repository, you'll find out that there is like a comparison table that says any rule, if it applies to version 3 or version 4, you'll find some rules that apply to version 3 and to 4, some to 4 and not to 3, and vice versa. For example, Effect Gen uses adapter is not needed anymore in Effect v4 because the adapter parameter has been deprecated, or generic effect services because Effect v4 has not the effect.service pattern. But usually all of them support v3 as well. Again, the LSP is about 90% the same as the previous one. There are some rules that I did not port it yet, specifically the code gen stuff, because I have not seen so many users use them. And now also we have an official CLI for doing code gen of, for example, interfaces from schemas and something like that. So it makes less sense for the LSP to do that.
Do you recommend using the TSGo LSP then for Effect v4? I recommend it. I don't care what Mattia says.
I mean, I would recommend it as well, mostly because things have changed a lot from like last year. We went basically from coding by hand like prehistoric men to having LLM spit out
Prehistoric men. We were
to
cavemen
have
last year,
LLM.
everyone.
Yeah, exactly.
Wow.
So given now we have like a lot of LLM coding, and now speed about how fast you give feedback loops to the LLM is very important, and the speed of which the TSGo version can output the diagnostic is like at least 7 times faster than the previous implementation. So you can just give your LLM, okay, type whatever you want on your keyboard and run the LSP, and eventually you'll find the solution.
I mean, and also like if you're not using TSGo in your project yet, you could just use it for the
Yeah.
LSP piece. Like you could still compile. Like we do that in V4. We use TSGo for some checks locally, but in CI we still run the regular TypeScript compiler.
Mm-mm.
So, so yeah, I mean, it's worth considering. Or you could just use the regular Effect Language service LSP if you're not ready to go in on TSGo yet. So.
Yeah, again, the beauty is that the settings are named the same, so you can basically have one place that configures it and then switch to whatever you want for the project, for the machine, for whatever you want.
This is an interesting question for you, Mattia. Many of the options, like prefer schema over JSON, seem like desirable defaults. Is there a way to just enable a strict mode and only disable a few that you don't want? Or
That's I have in my backlog now that I have again more performance budget. On my backlog, I want to implement a preset feature that right now all of the rules right now are by default follow the logic that if the rule adds something that would already have been a TypeScript error, the rule will go into an error. If the rule would add something that is an anti-pattern, will go into a warning, and everything else that means that you have code that can be improved will go into suggestion. That is like the current default and the current logic that the LSP follows, and that's mostly for allowing a seamlessly interchange between the standard TypeScript and the LSP version. What you are asking for is exactly what I want to work on next time, which is basically allowing presets. Because given the rules we have, we could have presets that say, for example, the presets effect native. And the effect native preset, for example, sets the severity to error for any rule that bans internals, like node built-in internals, fetch, or whatever. And so what you're asking is, yeah, that will be coded as a strict preset, and we will have basically one preset. So that way, what will happen is that when you will run your setup command, instead of asking if you want to customize the severities, what will happen is that it will ask you which preset you want to use, and if you choose custom, you can customize the severities. Otherwise, you can choose between some presets that we will code. And again, up to now, I have thought about 3 presets that are again effect native, which is ban every internal, fully adopt effect. Strict, which is basically banning everything that is an anti-pattern, and the other one is the default one, which is suggestions.
question again to Mattia: is the LSP extensible in the sense of adding custom rules? I think the answer is no, but I'm going to let Mattia answer.
No. The again, as we have maybe I explained myself wrong before, but the thing is that unfortunately, even the new LSP is written in Go, and the problem is that now you have the point where the compilation of your code happens is inside of the Go environment, in the binary Go environment. And so that means that one binary cannot load in Go plugins in a platform agnostic way. So even if Go had plugins, they could not be in JavaScript, because if they were in JavaScript, probably they will be way slower, because then you would have Go and a JavaScript engine inside of Go. Or if you had things like, for example, binary plugins, could be security issues. And again, this is the reason why the standard TypeScript Go at the moment does not provide plugins. The only way they provide is APIs, and those APIs are exported by the Go binary, and you can access those API via IPC calls. And now that I mention it, I would just want to mention as well that given the Effect TSGo is a straight replacement for the TSGo binary, that means that if you have some other tools that consumes the TSGo in order to have the APIs to get the diagnostics for a file or whatever, they'll be available to that tool as well, because again, we will export in the APIs our diagnostics as well.